So the topic is beam modeling approach. Before we talk about the beam modeling approach, let's quickly review what we have talked about in our first lecture. In the lecture 1, we talk about what the BIM is. Second topic we talk about in lecture 1 is the benefits using BIM in our current or future construction industry. We discussed the benefit from different perspectives. At the end of lecture 1, I give you the first lab session, and everyone know how to model a simple walls in the Revit user interface, the Revit software. In today's lecture, we will talk more detailed and technically how the BIM modeling approach works. And what's the difference between the traditional direct modeling. Therefore, the learning objective for today's lecture include the following 4 bullet items. First, at the end of this class, everyone expected to understand what the object-oriented modeling is. And second, to explain what the parametric modeling is and why we use parametric modeling in BIM. Third, hope everyone can list the benefit of setting constraints in parametric modeling in BIM. And the last one is from our lab 2, everyone is required to apply the parametric modeling to model the building components in BIM. So let's first talk about the object-oriented modeling. So what the object-oriented modeling is. So simply speaking, we can, instead of draw the line and curve and other basic geometric shape from scratch in AutoCAD software, we simply select the object which is already the components of each of the building's components, and then drag them and put them at the desired position or location for your model. It looks like a simple game. Put everything together. So that best concept is object-oriented modeling. So maybe it's too superficial, and let's step by step to go into to extend to more details about this concept. So this slide shows a residential building which is composed of many objects. So the left picture shows the architecture components, which I just give you some examples like roof, wall, windows, and doors. And the right picture shows the structure models, which include a beam, steel column, foundation wall, footing, concrete column, stair, slab, trusses, and elevation wall. You can see all of them which is already the structure or architecture components. It's not a simple geometrical line or rectangular box. It has its own name, own behavior, and properties. So let's look at the detailed properties of each object. If we select the wall in the architecture building models, this is the basic wall for exterior use, composed of brick and CMU on multiple start. If you click the Edit type, this pop-up window gives you all the detailed information. And some other constraints, I think some of the location base constraint, the top constraint, we already use that to help us to define the wall height in our first lab session. The next example is the window. If you click the window, you can find the type is fixed with the dimension 36 inch times 72 inch height. You click the Edit type, you can see the different values because the windows have different properties compared to the walls, and also the constraints, identity data, phasing, and other information listed here. So now you have a visual impression about what object-oriented model is. Now let's dig into some more technical level which behind this model, they have some documentation and definitions in the official website. I just use the Revit API, which is for the programming interface, communicate with other software. It defined its own wall class generalization. So generally speaking, the wall class is an abstract concept. It presents different kind of walls. As long as they are walls, it belongs to this wall class. Therefore, this wall class only have abstract parameters such as material. They don't define what the material is, but they need to they give the material properties that you need to input the specific material when you define a specific wall. Now let's first look at the wall method. Instead of the wall type, wall geometry, they also have the wall method. What's the wall method mean? That means the behavior. If you view the wall as an object, this object should also, beside the dimensions and some basic information, shape information, they also have some behavioral parameters, such as how to create a wall, and how to modify the wall, how to flip the wall, if they have the interior layer and the exterior layer, which are different. Next question is, shall we come up with one model, for example, one wall for every individual walls? Or we can rephrase the question is, can we group similar walls in a group or category and then come up with a common model for the group? So for example, we have wall ID, different kind of walls here, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 walls here, and the first 3 indicate the concrete wall, and the next 3 is the masonry wall, and the last 3 the dry walls. They use different materials, but all these walls belong to the wall class. So instead to represent all of these different walls, we will use one parameter, that is material, to indicate to cover all of the 3 walls, because the material is the abstract concept. You can give concrete, masonry, a dry wall, and the wood materials into this fill in this parameter. So next we talk about the wall properties. After we talk about the wall method, let's look at the wall properties. The wall properties means as we talk about, as I give the example, if you click the wall, they will pop up the wall property widget, and you can edit the type. It gives you different kind of properties you can modify. And this link gives you more information. If you're interested in this API document, you can look at. Since we are not the programmers, we don't need to know the basic definition in very detailed level. We just know, at least we know the wall class is the abstract class. It have the wall method, wall members, different kind of wall method, and wall methods and wall properties. I think that's enough. The next topic we talk about is the wall type hierarchy, which is here wall type properties. So generally speaking, we need to have a hierarchy order to organize different kinds of walls and put them into different categories, help us to quickly find the most common parameters and group them as subgroups. So this is a example, a tree, hierarchical tree I showed here. So it have in Revit, maybe in different software they have different hierarchical level, but in Revit the Revit software defined 4 different categories. The very top is the category. Category is an abstract wall type, wall class. it didn't represent any specific wall. It's just the concept or terminology. The second level is we call it family. This family group have different subgroups like basic walls, curtain walls, and stack walls. They have quite different parameters or types or construction process. Therefore, we put them into subgroup and help us to quickly find or organize the most similar wall types. If we look at the basic wall, this family, and look at each individual ones. These individual ones, the wall type, is the real wall type. And if we drag this exterior brick on multiple stars into our real models, into our beam models, and each specific walls here, for example, this is the wall we select, this is called instance. So this instance means this is one example of this exterior brick wall type of walls. So this is how the Revit organized these wall classes into different levels. So pay attention to this one, and in our exam or quizzes in the future, at least you need to memorize this 4-leveled hierarchical category in Revit definition, in Revit object-oriented modeling. Then the next question is, shall we, if the wall class is defined and for some reason we create a totally new type of wall, for example, Adobe wall, can we also incorporate the Adobe wall under the wall umbrella? So the answer is yes, because we expect for a good object-oriented modeling, the definition of the abstract class, the parent nodes, the root nodes, should be as robust as possible to first to include all the wall type, and meanwhile to differentiate the walls with any other structure or architecture or MEP component. Therefore, we can also include the Adobe wall into the wall type, because we only define the material, but we didn't give specific material for this wall. This is another good example or overall picture to look at the relationship and difference between the different components. Like the wall, you can see the wall is sitting here, and beside it is the floor, ceiling, roof, and windows, and this is the opening and doors. You can see all of these, their parent node is the building components, because the building components include all of them. It must extract the common things from all of these components. And then then we continue go up, and its element. Element maybe include MEP element, structure element, and a building element. And then we go up again, it's a product. Product include the site, building store, material, and geometry. And then go to the parent nodes. It's the root nodes are called object. So this is the most topest and abstract one. Then we go to the root. Root is the starting node, starting point that we do the programming, or we do the entity relationship definition for this organization chart. So if you are interested in this one for your research or your future study, you can go to this link, and to find more definition or explanation for this this class inheritance hierarchy in Revit programming. Okay. So the next question is, since we know the concept and the detailed information, technical detail about object-oriented modeling, and how does the BIM know the correct way to change the shape? So the second concept is parametric modeling. Generally speaking, now we have the wall. For example, this is the wall. We have the wall as an example, but in order to easily control or change the shape for this object, we need to give some quantitatively definition for each parameters, and then this model can representative by a series of parameters. If you want to change the shape, you can change the parameter for you can change the value for each parameter, and this model will automatically update it. So this is the idea of the basic idea of the parametric modeling. Now look at this example. The left, there is two doors with two different heights. The right door has 1 meter higher than the left one. So we look at the type properties, both left and right. You can see the only difference is the height, the value in the height parameter, this line of items. So that means if I type in a different number and then click apply button, this door will automatically update it. So this is the merit or the idea of the parametric modeling. So now the next question is, next I want to give you some basic concept of 3D modeling in computer graphics. Because when you look at the model, the model is actually the pseudo 3D. It's not a real 3D because the PC monitor is only two-dimensional. Now, in order to realize or achieve the 3D modeling visualization in computer graphics, we need to know some basic ideas. The first one is geometry representation. This is the form used in computer graphics to represent 3D models. Example is, the most common example is either you use a solid model or you use a shell or boundary model. The solid model is usually used for the analysis, which to analyze not the boundary shape of the object, but also the interior material structures, like strength, concentration, strength and strain, and some cracks. So this one you need to use a solid to model the structure column or beams, and then to do the 3D analysis. But for the gaming system, if we look at 3D game on our computer, in this case we don't care about what the inside of this model looks like. We only look at the shape. So in this case, when you play the game on the gaming engine or system, they prefer to use the shell or boundary of the object, which can keep the high performance when you're playing the game. The grammar structure. Second concept is grammar structure. This is a set of geometric primitives and operations to construct any 3D model. So the most common method is B-Rep and CGS. We will talk about this in the following slides. And then the modeling process is the process or procedure we need to follow to build the 3D models, either direct modeling or parametric model. We will also compare the difference. So in order to compare this difference, we first need to know this difference for the geometrical representation and the grammar structure. Then to help us to better understand this concept, the modeling process. Okay. Now, next let's talk about the grammar structure. We use the two typical or representative approach to give you some basic prerequisite knowledge. The boundary representation approach and the constructive solid geometry approach, CSG. So the BRAP method means BRAP represents the shapes as a closed-oriented set of bounded surfaces. Usually it is used for visualization, measuring, clash detection, and other non-editing purposes. So there are some pictures show the idea. For example, this is a cylinder. We can use the rectangular shape, 2D rectangular shape, and to rotate along the center line for 360 degrees to come up this cylinder. Similarly, we can use a rectangular 2D shape to rotate and then come up the cone shape. It's quite simple, just a rule, either rotate or a translation. The second one, CSG approach. This approach includes a set of operations to combine different kind of basic shapes from BRAP, for example. This is one example. To get this shape, we need to do the following operations. The left branch, we use a cubic and a sphere, and then to do the union operation, this one, and to get this shape. And on right branch, we use the three cylinder along different directions, 3 axes, the direction X, Y, Z, and to come up this one, use the union as well. Then we use this one to subtract this one, we can get the final result. So it's much more complicated than the first approach, but it can get more complicated shape. It's usually used for editing in 3D solid modeling purposes. So the first BRAP is usually used for the simple shape or simple, either the 3 solid or a shell object. Okay, after quickly explain these basic terminologies, we can go to the comparison between direct modeling and parametric modeling. For the direct modeling, I provide 2 video link. You can click this link and look at these examples. Then after look at these 2 video links, you keep a question in your mind: what is direct modeling? And you can use your own words based on your own understanding to explain. So let's quickly give you the result directly. Because we don't in class, I will not show you, wait the video to plan for you. So the direct modeling, the advantages is it can directly operate the geometrical shape. It don't have any constraints like the walls or doors or windows. They don't have specific purposes or specific name. It's just the shape. So have no other information. So it is good for freestyle 3D creative modeling and designing. For example, in the video I show in this slide, this one, the YouTube link, it gives the example for direct modeling in AutoCAD Inventor software. That software is targeted the user groups which do a lot of creative modeling or designing works or jobs. And it's also suitable for model editing when the existing model doesn't keep its historical data and features defined in parametric modeling. For example, I create a wall in the Revit, then I export this model, and during the exportation I lose all the information related to the object, just the geometric shape. So in that words, when you receive this model from the designer, maybe they just want to protect their design details. You only have the boundary, then based on this boundary, the only choice is to do the direct modeling. You don't have any model behavior or object behavior. So the cons or the disadvantages, you need to draw and edit the 3D model from the basic geometrical shape, such as the length, the breadth, and height. You cannot directly drag the model from the library and put in your desired position. The more detail can be found from this link. Now next is parametric modeling. I believe everyone already in lab 1 already knows some basic concept about all the parameters looks like. And so the question, you can also look at the YouTube link to help you have more understanding about parametric modeling. So the question 2 is, what is parametric modeling? What's the difference between parametric modeling and direct modeling? A more detailed discussion can be found from this link. So generally speaking, the parametric modeling have some benefits, which is very good for BIM software modeling approach. First is its ability to easily capture the design intent, which make it easier to define how the model should behave when something is changed. Second, its easy definition and automated creation from the family or family types. It automatic update to the model if changes are made to the design. So the designers only need alter one parameter, the other two parameters get adjusted automatically. For example, they have some constraints. And second is the designer need only alter the parameter of one model, and the other remaining models can get adjusted automatically as long as they belong to the same object or family type. The fourth merit is its excellent integration with manufacturing process, resulting in a decrease in production time. So do you remember the project case I showed you for the direct manufacturing of the steel assemblies for the Beijing National Stadium in the Olympic 2008, right? 2000. Cannot remember the date, the year. The Beijing Olympic swimming stadiums. So the cons or disadvantages is during the concept design, parametric modeling may be overkill for designers who trying to investigate because they want to investigate as many 3D concepts of an idea as quickly as possible, then share with other designers. And second is parametric modeling take more time to update when unexpected design changes are needed. So that means at the very beginning of the design, the direct modeling is more appropriate. Then later, when your general shape of the model is fixed, and you'd better choose a parametric modeling to help you to the modular design and modular manufacturing. So this is the link and more discussion as well. So now after the comparison, which is better, direct or parametric, the answer is both of above. Depend on what purpose you want to use and what phase you are in your design work you are. So while each has its benefit, so therefore some CAD software use both approaches to do the modeling. For example, in AutoCAD Fusion 360, they have one option that is a design history. If you select the capture the design history, which is more related to the parametric modeling. If you don't capture or you don't have the design history, it's usually the direct modeling. But in the BIM software, since it's object-oriented, it already have the fixed wall, fixed door. It's already the standard size and the default system family type already. This library already. We prefer to use most of the cases we use the parametric modeling. However, if you go into the detail edit some parameters or to customize some model based on the existing model. In this case, sometimes you need to combine both parametric modeling and direct modeling as well. So the best designers need to use both of them correctly to make their work creative and meanwhile efficiently. Then the parametric modeling in BIM, I can give you some example. The first example I already gave you in our lecture 1 is the parametric modeling has the topological relationship can reflect assembly constraint. For example, you put a door into a wall, the wall can automatically measure the size of the door and open and hold or cut a hole to fit the door. The second example about assembly constraint is the wall-to-wall example. If you put two walls together and look at the intersection corner, the wall will automatically cut the overlaid part and to merge them as the one piece. More topological constraint for walls. I list several examples here. You can look at all of them, maybe in the following lab or in your future work or intern when you use the BIM. You need to keep this in mind. The software can do this kind of things. And this example, I provide a video. The idea is the assembly constraint between the wall and the roof. It can fill in this slope automatically, and then when you change the shape of this slope of this roof, it will automatically fill in this change. Of course, if you don't want to make them automatically connected, there is also a checkbox to uncheck that checkbox. Then this hole will not be fit. The wall will not automatically fit into connected to the boundary of the roof. Therefore, you have more choice. So it's doable and it's editable, this option. Another topological relationship reflects the assembly constraint, the wall, door, and the column dimension example. So you can look at this video and you pause at 8 minutes. That's enough to give you these ideas. So therefore, the take-home message for parametric modeling BIM is parametric modeling addresses two things. First is geometry of the object, like the door, we can change the height. And the second is the most important thing is the topological constraint, which discloses the connection relationship between the objects and allows the users to create many instances of the same object with different dimensions by simply change the parametric parameter values. Assignment 2 is the reading assignment. You read the paper in the Blackboard. I upload in the Blackboard. The subfolder is reading materials, and the paper's name is this one. It reviews the recent studies and progress using BIM between 2005 and 2015, and also gives some insight and the future trend in use of BIM in AEC industry, construction industry. And in order to make sure you read through this paper, I will give an online quiz, which the duration is 50 minutes at the beginning of next Thursday's class on June 6th. So make sure you read this paper. Even though I allow you to open this paper when you do the online quiz, but make sure you read it already. You have some ideas, and then you can find the right place to look at the detailed information to finish your quiz. It's only 50 minutes. Okay. The last thing I want to talk about is lab 2 we missed. So to make up, we will do this lab 2 with the lab 3 together, and hopefully we can finish it next Tuesday's class. This is the lab 2 instruction here. The learning objective is use a proper procedure to create architectural building elements in Revit, which include architectural columns, slab, and floors. I also provide the Lab 2.0 Revit model to you on the Lab 2. You can follow these lab instructions to create columns and slab and floors. The expected result 3D model looks like this. So you will need to submit the final Lab 2 Revit model through Blackboard. The due date is next Tuesday, 8:30 p.m. Okay, so this is all for the Thursday's class we missed. Hope everyone had a good weekend. Bye.